Energy efficiency in the home is an issue with which we all need to be concerned. And at the heart of an energy-efficient home is the selection of a heating and cooling system which can provide the most efficiency and comfort for your energy dollar. Now today we'll focus on one aspect of this comfort system that is probably the most serious home energy loss problem discovered in over 20 years. And most people didn't realize until recently how serious it is. We're talking about duct system leakage. Now in Florida alone, millions of dollars in home energy bills are wasted each year because of duct system leakage. And the problem is widespread throughout our nation, where the waste in energy dollars is estimated to be several billion. Studies indicate if duct leakage could be prevented or repaired, homeowners would save anywhere from 10 to 30% on their central air conditioning and heating bills. That's why Florida's utilities are working together to promote a better understanding and solution to this problem. Now, in addition to energy losses, duct leakage can cause moisture and comfort problems in the home. It can promote damage to building materials and even endanger people in the home by drawing hazardous materials and fumes into the air they breathe. Also, when sizing the equipment and designing the duct system, you should know or be aware that air conditioning load calculations assume there is no duct leakage. So if the ductwork is not completely sealed, the equipment you install may be undersized simply due to duct leakage. Now, a quality duct system installation is necessary to achieve maximum comfort in the home. And from the customer's view, we shouldn't settle for anything less. Think of it this way. If your plumbing or electrical system had a leak or short, you would consider it unacceptable. So why should the air distribution system be any different? In order to understand how an air distribution system maintains comfort, we must first understand the components of the duct system and how they relate to the overall effectiveness of the heating and cooling equipment. Now, all central forced air systems begin here at the return grill. From the return air chamber, the airflow continues through the air handler. Conditioned air is then evenly distributed by the main plenum and supply trunks to individual branch line ducts that lead to supply registers just like this one. Now, your air distribution system is designed to be a closed-loop, pressurized and balanced system. And that means that the same volume of conditioned air supplied to the living area is to be circulated back to the return air grill so it can be reconditioned and distributed again. To illustrate our story, we'll use a typical installation during the cooling season. Heat flows into the house by three methods: radiation, conduction, and natural air infiltration, sometimes referred to as air changes per hour. Now, this uncontrolled air infiltration represents what an air distribution system affects so greatly. When the air handler is on and there is no duct leakage, it has little or no effect on house infiltration, as shown here. But once you add air duct leakage, the entire dynamics of the house system changes. The impact on home might increase infiltration by 2 or 3-fold and could cause discomfort, leading to moisture and potential indoor air quality problems. Duct leakage could occur in many areas. However, the most dominant leakage usually occurs directly before and after your indoor air handler. And that's simply because it's where the greatest amount of fan pressure exists. Return air leaks represent the greatest and most common leakage areas, which means this is where the most energy is wasted. The diagram shows that a 15% return air leakage could reduce system efficiency and capacity by approximately 33%. This means higher operating costs for consumers and additional callbacks for contractors. Supply leaks do just the opposite of return leaks. They not only lose conditioned air to the outside, but they tend to cause a negative pressure to the house, resulting in more air changes per hour through the home's natural infiltration routes. Now that you know how and why duct leakage develops, let's look at a typical house and identify where leaks occur and how they can be sealed. As mentioned before, most leakage occurs near the air handler unit. This can be divided in two areas, above and below the support platform. First, Let's look at the return air chamber directly below the support platform. The first step when examining the return air chamber is to inspect the air filter for dust or debris. The walls, in this case, are open to the top plate where hot, humid attic air can be easily drawn through any cracks or holes. The chase line also appears to be open. Let's go outside to determine if it's sealed at the outdoor unit. As you can see, it's not sealed. It's pulling in unconditioned outside air into the air distribution system. The next area to check is above the support platform. It's relatively easy to check with the air handler turned on and starting with the platform itself. Look for any leaks or cracks around any joints at the base of the air handler where it mates to the support platform. Refrigerant line hole penetrations and the edges of the platform itself. As we move up the mechanical closet and air handler area, you may notice more leaks around joints, some duct tape loosening, unsealed cracks, and penetrations in walls and ceilings. Finally, let's check for supply leaks in the attic. They generally occur at joints in trunks, branches, and boots, as well as between the boot and ceiling itself. Also, it is possible that some unintentional holes in the trunk may have been unnoticed and left unsealed by installation mechanics. How can we prevent air duct leakage and assure an airtight system? Well, compared with the problems of duct leakage, the solution is really simple. In new home construction, the duct system should be carefully designed and thoroughly sealed, as prescribed in the Florida Energy Efficiency Code. To accomplish this, shown here are a few of the materials you may use in achieving the airtight system. It's easy to install. All you need is a paintbrush, approved mastic and tapes, reinforcing fabric, duct board, and of course the appropriate tools, and you're ready to go. Now there are several types and different ways that distribution systems are installed in the field. But these basic materials are applicable in both existing or new home markets. Now that we've identified the common sealant materials, let's look at how they may be applied in the field. In the return chamber below the support platform, a combination of duct board and mastic with embedded fabric is one of the best methods to assure an airtight system. After completion, your return air chamber should look something like this, complete with chase pipe and walls, sealed, airtight. In slab construction, after the refrigerant and condensate piping has been installed, all openings to the outside must be sealed with reinforced mastics or mixed cement or an equally durable substance. Above the platform, a supply of approved mastic or tape can usually seal any air leaks in the mechanical closet area. And make sure you observe all safety and code requirements when sealing around electrical fixtures and combustion appliances. Also, as an additional and significant benefit, sealing these leak sites could further enhance your indoor air quality by eliminating any potentially hazardous fumes or contaminants from entering the home through your air distribution system. And finally, let's look at proper installation practice and techniques for the supply side of the air distribution system. With reinforced mastic as your primary sealant, you can usually close up holes in the trunk line and seal most leaks at branch line connections. As demonstrated here from the beginning, proper application of embedded fiberglass mesh with mastic creates a bond between the trunk, the fittings, and branch line to form an airtight seal that will last the life of the system. It's an old idea called attention to detail, or just plain good workmanship. As we've seen here today, using a properly installed air distribution system is one of the most important aspects of an energy-efficient home. An airtight, properly designed duct system can offer increased home value through quality, comfort, and reduced energy consumption, which in turn helps your local utility lower its peak demand, cutting everyone's energy costs. It doesn't matter if you're a homeowner, a contractor, or a utility representative. It's up to you to take on the responsibility for our environment and the world around us. What we can conserve today, we can enjoy tomorrow.